Hey everyone, this is Darshan Senthil from IPLgeek.com, and I come with you with another math video today, this time about standard form in linear equations. Now this may seem like something different from what we've been learning so far, but it really isn't too far from what we've been doing. So let's just look over what standard form is exactly. And it's just basically another form of linear equations, like I just said. It's just another way to write it. Now what we've been going over so far has just simply been this: y equals mx plus b. And this is our slope-intercept form. Slope-intercept form. So this is just basically been our slope-intercept form, and it's called that because it's got a slope and an intercept, as we have studied in previous videos. Now what we're going to be looking at is something called standard form, which is basically the same thing except it's rewritten slightly. So let's take a look at that. So it's basically written as follows: ax plus by is equal to c. Now you might look at this and you're like, whoa, what are these? But honestly, it's not that hard. I'm just going to explain it to you in just a minute. So let's just pull this equation apart and see what we can decipher from it. So first up, just notice that we've got our x and our y here, a y, and that's our x. So they are just simply the x value and the y value. Nothing different about them. They're exactly the same thing as they are in this equation. The x and the y have the same role as they do. Now the only new factors we have here are this a and this b. Now what would these be? Well, these two guys are simply gonna be some extra coefficients. They play kind of the same role as slopes, but they apply to both the x and the y for a change. So this is what that is. So yeah, ax plus by, and that's gonna give you c, and these are our coefs. So the c, now what's the c? Now the c is a constant, and it's just going to be a number like 30 or 25, and notice that it has no variable next to it. So this is just going to be a number by itself. You're not going to have anything else near it, just a number like 32, 27 and stuff like that. So same thing with these, like this a and this b will be numbers. They're just substituted with a and b here for any numbers, and this x will remain as x and the y will remain as y. It's the same principle as a linear equation, as a slope-intercept form, except you've got different letters and a few more letters at that. So I hope you got that. I'm just gonna write down a quick example for you of what a linear equation would look like. So for instance, 3x plus 2y is equal to 6. This would be what a standard form linear equation looks like. So having said that, let's just get on to how we could solve some of these equations and actually draw lines for them. Okay, so in this example I'm gonna just show you how you would graph an equation like this. I just made one up real quick. So graphing an equation like this is fairly simple. Of course, you could convert this to slope-intercept form, which is y equals mx plus b, but that's just kind of time consuming. So it takes a while, and if you prefer it that way, that's fine with me, but there's actually an easier way to do this, and that is actually by finding what you call your intercepts. Now we already know what an intercept is, and that's because we know what our y-intercept is. And our y-intercept is, as we know, y when x is equal to 0. So the same thing is, you also have what is called your x-intercept, which, using the same logic, is x when y is equal to 0. So that's basically all there is to it. That's all you need to do to find your intercepts. So what we could rewrite this as, I'm going to do this in a slightly different color. So to find our intercepts here, what we could do is we could just say, if we want to find our x-intercept, we know that y is going to be equal to 0, so we can just rewrite this as 3x plus 8 times 0 is going to be equal to 24, because we don't know what our x-intercept is, but we know that what our x-intercept is going to be there only when y is equal to 0. Okay, if you follow me? So yeah, that's what we do. So then what's 8 times 0? That's 0. They just cancel out like this, so we can just leave them out of the equation. So now I'm just going to rewrite this. 3x is going to be equal to 24. And then we can solve this fairly easily. Divide both sides by 3 and you get that x is equal to 8. We can do that on our calculator here as well. So what's that? 24 by 3 is going to give us 8. So yeah, we didn't really need a calculator, but in case you wanted to just see it, we could do that as well. So yeah, x is going to give us 8. So this is going to be our x-intercept. Now let's find our y-intercept. I'm going to do this in a different color as well. So we're going to use yellow for this. So same logic, we're going to use the same principle here. So what our y-intercept is going to be, that's going to come when x is going to be equal to 0. So we're just going to rewrite this. I'm going to do this down here as 3 times 0 plus 8 times y is going to give us 24. So again, these two will cancel out, so we're left with 8y is equal to 24, and then we can check what that is in our calculator. So that's going to be 24 by 8, that's going to be 3. I picked fairly simple numbers for this, but just using the calculator just to make sure everything is shown clearly. So yeah, we divide by 8 and then we just got our answer, and x is equal to 3. So I'm sorry, y is equal to 3. Okay, so now we have our x and y intercepts. We're just gonna plug them in. So yeah, I'm just gonna do this one. I'm gonna plug my y-intercept in with yellow. So when x is equal to 0, y is gonna be equal to 3. So that's 1 point on our line. Yeah, I'm not sure if you can see that very clearly, but that's right there. And then I'm just gonna do this one in red. So when y is equal to 0, x is gonna be 8. So that's 1, 2, 3, 4, 5, 6, 7. It's gonna be, I'm just gonna put it out here. So these two are points on our line. We know, now using this we've determined that these two are points on our line. So now I'm just gonna, and it's a geometric principle, as you know, that through any 2 points there is exactly one line. So now we can just simply draw out our line through this, and I will do that just now. So yeah, I'm just gonna do that in red. Make sure that's on the dot. You should always make sure that your lines are passed through these points almost perfectly, because if you don't, then it's gonna look slightly sloppy and you might lose points for it. Okay, so that's a nice snazzy dashed style. And then yep, so that's how you would graph them. All you need to do is just find your intercepts and graph them. This actually takes only about 5 seconds if you have something this easy, but I just took it step by step so you can see the process that goes on here. So I hope you understood that, and let's just do another little more tougher example over here. Okay, so in this example the question's just asking for us for a little bit more than just a graph, so we're just gonna have to think a little bit extra here, but still it's nothing too hard. Okay, so let's just read the question here. An honor society has $150 to buy science museum and art museum tickets for student awards. The number of tickets that can be bought is given by 5s plus 7a is equal to 150, where S is the number of science museum tickets at $5 each, and A is the number of art museum tickets at 7 each. Graph the equation and give 2 possible combinations of tickets that use all $150. So basically what this is saying is that they can buy a certain number of science museum tickets at $5 each, and they can buy a certain number of art museum tickets at $7 each, but whatever that is, it should not exceed the sum of 150. It's got to be less than or equal to $150. So okay, wait, let me just, that's not a good 7. I'm just gonna rewrite that part. 7a is gonna be equal to 150. Okay, so this is basically all that's gonna say. Now we're gonna just do this the same way as we did the other one. We're just to graph this, we're gonna do the same thing as we did for the other one. We're just gonna find our intercepts and we're gonna place them on the graph and graph them. Okay, so we'll start with our x-intercept. So this is basically going to be like our x and this is going to be like our y. So hope you just don't get confused by the different variables. Just look at it as x's and y's. So we're just going to do it that way. Okay, so let's go. So 5, which is going to be our x-intercept. So 5x plus 7 times 0 is going to be 150. So this will cancel out. So 5x is going to be 150, and if you divide that, x is going to be equal to 30. So this is going to be our x-intercept. Now for our, let's see, let me use blue. So for our y-intercept, I'm going to make this in blue. So okay, so 5 times 0 plus 7y is going to be 150, and then this will cancel out, so 7y is going to be equal to 150, and then if you divide both sides by 7, y is going to be equal to 150 by 7. So these two are intercepts for this problem. Okay, so now, whoopsies. So now we're just going to basically put these points on our graph. So y is equal to 30 because the scale is on 10. This is a 10 scale, don't forget. So 10, 20, 30. So this is where, so wait, no, it's going to be over here. So 10, 20, 30. That's where our x-intercept will lie. And then y is equal to 150 by 7. We're just going to use our calculator to approximate where that might be, because 150 by 7 is not a whole number, so we can't really tell that easily. So we're just going to use our calculator to check where that might be. 150 by 7, that's going to give us 21.42. So this is going to be somewhere around, right about over there, right around the 20 mark. So that's where that would be, and we're just going to do that one in blue. Just going to take the color from there. So right about there. It's not perfectly 20, but it's really close to it. Okay, so that's what that is. And now we're just gonna draw a line through those 2 points. It's important to make sure that they go through the points you want them to, and also try to make sure that your lines go to the ends of the graph, so that you know that these lines are extending indefinitely, or else you might lose points for inaccuracy. So yeah, that's our line. And then now the second part of this question says that we need to find 2 possible combinations of tickets that use all $150. So for that, all we're going to need to do is pick out 2 points on this graph that fully satisfy this equation. We're just going to pick out 2 points that satisfy this. And an easy way to do this is to plot this equation on your graphing calculator, turn this into slope-intercept form, and put this on slope-intercept. Put this on a graphing calculator. And then just go to your table and find 2 sets of whole numbers and that work for this. That would be an easy way to find it, but since I don't have a graphing calculator put up here, I'm just going to show you, I'm just going to approximate here, and then we're just going to see how that would fit. Okay, so we're just going to approximate over here. So actually, if you look at it, the point 220, which is about right there, somewhere over there on the line. It's about 2 this way and 20 this way, so that kind of works. So we're just going to experiment with that on our calculator over here. So 2 times 5, that's going to give us 10, plus 7 times, what is that, 20. 140 plus 10 from the previous part, it's going to give us 150. So that would work. So the coordinate 2, 20 is one that works for this equation. So this is one answer. And for another one, we're just gonna need to look a little bit deeper here. Just keep in mind that we cannot use negative numbers for this particular problem, since you cannot buy a negative number of art museum tickets. That's just inappropriate for the situation. So be sure that you pick answers that are appropriate to the problem. So this side is pretty much out and this side is pretty much out. So all we're focusing on is these couple of answers here. We're going to need to pick our answers from this part. Please do not. If you write a negative number for your answers, your teacher's going to throw you out. It's going to just hit you with a textbook or something. So because you can't buy a negative number of tickets. While this would work in a regular problem, like if I just gave you this equation and said find your intercepts and find 2 points, you could do that. But for a real life problem, please do pick whole numbers or somebody's gonna get mad. So okay, another point that would probably work if my calculations are right is, if you actually look here, then that's approximately 15, and that lines up with what could be 9 over there. So that could be a point on the line as well. So 9 and 15. So we're just going to test that as well to be sure. Always test your answers, because sometimes you may look at things that they may seem to be correct, but if you might have made a mistake somewhere while finding, so you could be wrong. So just be careful when you check just make sure you check your answers once as well. So we're just going to do that right there. So 9 times 5, it's going to be 45, and then 7 times 15, it's going to be 105, plus 5 times 9, which is our 45. And if you add 45 to this, that's going to give us 150 as well. So these 2 points work. So these 2 are points that work on this. So once again, they would be a lot easier if you just had a graphing calculator. You could go to your table or use your trace key function or stuff like that, and you'd be able to find 2 whole number points that fit. I would not advise you to put decimal answers, because you cannot buy 2.5 tickets just as much you cannot buy -2 tickets. So try to find whole number answers, and yeah, just make sure you think properly when you solve that. And yeah, just look in your if you have a graphing calculator, then this problem could be like 5 times easier. You will not have to approximate, but all the same, yeah, approximation can be like a backup for you. So yep, once again, thanks for watching the video. I hope you enjoyed it. Please do subscribe, check out some of my other math videos, and be sure you understand this video carefully, because standard form is going to be important for our later chapter on systems of equations and stuff like that. So once again, yeah, I hope you enjoyed the video, and please subscribe, leave comments, check out some of my other genres of videos as well. I've done chess and cricket podcasts, so check those out, and yep, just tell me how I'm doing. I really appreciate constructive feedback. So yep, thanks for watching.